If the moon disappeared tomorrow, Earth wouldn't just be darker. It would slowly become unlivable. We take our celestial neighbor for granted, a beautiful silver orb in the night sky. But what if it was never there to begin with? What would an Earth without a moon even look like? The answer is terrifying. It's a world you wouldn't recognize, and a world that might not have even given birth to us in the first place. To understand why, we need to travel back in time, way back, about 4.5 billion years ago. The early Earth was a chaotic, molten mess, spinning wildly. Then, disaster struck. A Mars-sized protoplanet, which we call Theia, slammed into our young world. This colossal impact was the most violent event in Earth's history. It was so powerful it tilted our planet and ejected a massive amount of molten rock into orbit. Over time, gravity pulled this debris together, and it coalesced to form our moon. This giant impact hypothesis is the leading theory for the moon's origin, and it set the stage for life as we know it. So, let's run the simulation. What if that impact never happened? What if they had just flew on by? The first thing you'd notice on this moonless Earth is the speed of the day. Remember how that impact tilted Earth and slowed its rotation? Without that cosmic break, our planet would be spinning much, much faster. A day might last only 6 to 8 hours. Imagine that. 3 hours of daylight, 3 hours of night. Your sleep schedule would be a mess, and plants and animals would have a crazy time adapting to such rapid cycles of light and dark. But the short day is just the beginning. The faster spin would create winds unlike anything we experience today. We're talking about constant, planet-sweeping super hurricanes, with wind speeds easily exceeding hundreds of miles per hour. These aren't just storms. They would be the permanent state of the atmosphere. The surface of the planet would be perpetually scoured by these ferocious gales. Building anything would be nearly impossible. Trees, if they could even grow, would be ripped from the ground. Life would have to hunker down, perhaps evolving underground or in the deepest oceans, just to survive the relentless atmospheric violence. Speaking of oceans, let's talk about the tides. Our moon's gravity is the primary force behind the ocean tides we see today. It pulls on the water, creating a bulge that results in high and low tides. Without a moon, tides wouldn't disappear completely. The sun also has a gravitational pull, but it's much weaker. So, on our moonless Earth, the tides would be only about 1/3 as strong as they are now. That might not sound like a big deal, but it's huge. The regular ebb and flow of strong tides created vast, dynamic coastal environments called intertidal zones. These zones, where land and sea meet, were rhythmically washed with nutrient-rich water. Many scientists believe these tidal pools were the perfect primordial soup kitchens, the ideal cradle where the first simple life forms could emerge from the oceans and begin to experiment with life on land. Without strong tides, this crucial stepping stone for life's evolution might have been missing. The transition from sea to land could have been delayed by billions of years, or it might have never happened at all. But perhaps the most catastrophic consequence of a moonless Earth would be the climate instability. Our moon acts like a giant stabilizer, a gravitational anchor that keeps Earth's axial tilt steady. Our current tilt is about 23.5 degrees, and the moon's gravity prevents it from wobbling wildly. This stable tilt is the reason we have predictable, reliable seasons. Summer, fall, winter. Spring they happen, because different parts of the Earth get more direct sunlight as we orbit the sun. This predictability has allowed life to adapt and thrive, knowing what to expect from the climate year after year. Without the moon, our axial tilt would be chaotic. It could swing dramatically over millions of years, from 0 degrees, where there are no seasons at all, to extreme tilts of over 45 degrees. Imagine Earth tilted on its side. The North Pole would point directly at the sun for half the year, experiencing a scorching, non-stop summer, while the South Pole would be plunged into a decades-long freezing winter. Then they'd switch. The equator might become a permanent ice belt. These climatic swings would be so extreme and unpredictable that it's hard to imagine how complex life could ever get a foothold. One millennium might be a global greenhouse, the next a frozen snowball Earth. Evolution wouldn't have a stable playing field. It would be a constant game of survival against planetary chaos. So, when you piece it all together, a picture of this alternate Earth emerges. It's a planet with dizzyingly short days, howling superwinds that scour the surface, weak tides that may not have nurtured early life, and a chaotically unstable axis that creates wild, unpredictable climate swings from extreme heat to deep freezes. It's a world that is deeply hostile to the development of complex life. Simple microbes might still exist deep underground or in the oceans, but the evolution of plants, animals, and eventually, intelligent beings like us becomes incredibly unlikely. Thea's cataclysmic collision with Earth wasn't a disaster. It was a cosmic stroke of luck. That impact didn't just give us a beautiful light in the night sky. It gave us the stable, predictable, and relatively calm planet we needed to exist. It gave us longer days, gentler winds, dynamic tides, and reliable seasons. The moon is not just a rock in orbit. It's our planet's partner, a silent guardian that shaped our world and made it a haven for life. So the next time you look up at the moon, remember it's more than just a pretty sight. It's a reminder of the violent, chaotic, and incredibly fortunate history of our planet. It's the anchor that keeps our world stable, the clock that sets our ocean's rhythm, and a crucial piece of the puzzle that allowed for our very existence. Without it, Earth wouldn't be Earth, and we almost certainly wouldn't be here to wonder about it. Have you ever looked up at the night sky and wondered how the moon got there? It feels like a constant, a silent guardian that's always been with us. But what if I told you there was a time, a single terrifying day, when Earth almost lost its moon forever? This isn't science fiction. It's a dramatic story written in the scars of our solar system, a cosmic collision that almost rewrote history. Imagine our planet, billions of years ago. It's a young, chaotic world, and it has a companion, a newly formed moon, much closer than it is today, looming huge and beautiful in the sky. Life is just beginning to stir in the primordial oceans. But out in the vast, dangerous expanse of space, something is hurtling towards us. A rogue object, a massive asteroid, or perhaps a wandering protoplanet, is on a collision course not with Earth, but with our moon. This isn't just a stray rock. We're talking about an object hundreds of kilometers in diameter, a mountain of cosmic debris traveling at unimaginable speeds. Its path was a matter of pure chance, a gravitational nudge here, a slight trajectory shift there, over millions of years, all leading to this one fateful moment. For the young Earth, this event would have been an unbelievable spectacle. Let's travel back in time, to that very day. The sky would have been dominated by the moon, appearing 10 to 20 times larger than it does now. Then, a new star would appear, a tiny speck of light getting brighter and brighter, faster than any comet. It wouldn't have been a gentle approach. Within hours, it would grow from a point of light to a visible disk, a harbinger of doom aimed directly at our celestial partner. As it drew closer, the gravitational forces would have been immense. The surface of the moon would begin to crack and buckle under the strain. Chunks of rock and dust would be ripped from its surface, forming a temporary, chaotic ring system around it. The asteroid itself, heated by friction and gravitational pressure, would be glowing, a terrifying ball of fire screaming through the void. And then, impact. The collision would have been cataclysmic, an explosion of energy beyond human comprehension. It would have outshone the sun. On Earth, even though the impact was hundreds of thousands of kilometers away, the flash would have lit up the sky, turning night into a blinding day. Anyone or anything on the Earth's surface would have witnessed a second sun being born in the heavens. The impactor wouldn't just create a crater. It would vaporize. A vast portion of the moon's crust and mantle would be instantly liquefied and thrown into space. A colossal plume of molten rock and superheated gas expanding outwards at incredible speeds. This wasn't a simple dent. It was an event that threatened to shatter the moon completely. Imagine the aftermath. The side of the moon facing the impact would be an ocean of lava, a glowing, bubbling wound thousands of kilometers across. The shockwaves would race around the moon, triggering moonquakes of unimaginable magnitude, shaking its very core. The opposite side of the moon, the side we now call the far side, would experience the brunt of these focused shockwaves. The ground would heave and rupture, creating a jumbled, chaotic landscape completely different from the side that faced the initial blast. This is not just a theory. This event, known as the South Pole Aitken Basin Impact, is the leading explanation for one of the most profound mysteries of our moon: why the near side and the far side are so dramatically different. When we look at the moon, we see the familiar man in the moon, the dark patches called Maria or seas. These are vast, smooth plains of ancient volcanic basalt. But the far side? It has almost none of these. Instead, it's rugged, mountainous, and covered in countless craters. It's thicker, rougher, and geologically distinct. For decades, scientists were puzzled by this dichotomy. Why would one side be so different from the other? The South Pole Aitken Basin provides the answer. It's the largest and oldest recognized impact basin on the moon, and one of the largest in the entire solar system. It's a colossal scar, over 2,500 kilometers in diameter and 13 kilometers deep, located on the lunar far side. This is the wound from that ancient collision. The sheer energy of this impact did something incredible. It didn't just gouge out a massive crater. It sent a shockwave of heat so powerful that it traveled through the moon's interior. This heat wave is believed to have concentrated rare earth elements and heat-producing elements, like thorium and potassium, on the opposite side of the moon, the near side. Think of it like hitting a ball of clay. The impact on one side causes a bulge and change on the other. This concentration of heat and radioactive elements beneath the near-side crust acted like a giant stove burner. It kept the mantle on that side hotter for longer, allowing magma to well up and flood the surface for hundreds of millions of years after the impact. These massive lava flows filled in the older craters, creating the smooth, dark Maria that we see today. Meanwhile, the far side, having had much of its internal heat blasted away or redistributed, cooled down much faster. Its crust became thicker and more rigid. Without that persistent internal heat source, large-scale volcanism never took hold. So, it remained a heavily cratered ancient surface, preserving the record of its violent past. So the very face of the moon, the comforting sight we've known for all of human history, was shaped by this one catastrophic event. The man in the moon is essentially a ghost of this ancient cosmic collision. But what if the impact had been just a little bit different? What if the asteroid had been larger or faster? The moon could have been shattered into 1,000,000 pieces, creating a massive ring of debris around the Earth, much like Saturn's rings. It would be a beautiful but deadly replacement. Earth would have lost its stabilizing partner. The moon's gravity is crucial for life on Earth. It stabilizes our planet's axial tilt, which gives us predictable seasons. Without the moon, Earth's axis would wobble chaotically, leading to extreme and rapid climate shifts. One century might see lush tropics at the poles, and the next could see them covered in ice. It would be incredibly difficult for complex life to evolve and thrive in such an unstable environment. The moon also drives our tides. These tidal forces were essential for early life, creating intertidal zones that may have been the very crucible where life first crawled from the sea onto land. Without the tides, the story of life on Earth could have been very different, or it might not have happened at all. So, in a strange way, this catastrophic collision that nearly destroyed the moon was also essential for making it the perfect partner for Earth. The impact didn't just scar the moon. It fundamentally altered its geology, which in turn influenced its gravitational relationship with us, and ultimately the conditions for life on our own planet. The next time you gaze up at the moon, remember its violent and dramatic past. It's not just a rock in the sky. It's a survivor. It wears the scars of a cosmic battle that it almost lost, a battle that reshaped its face, and in doing so, helped pave the way for our existence. That calm, silvery light is a reminder of the chaos and violence of the early solar system, and a testament to the sheer chance and cosmic fortune that allowed life to flourish on this pale blue dot. It's a powerful thought, isn't it? That our destiny is so deeply intertwined with a catastrophic event that happened billions of years ago, hundreds of thousands of kilometers away. The universe is a dynamic, and sometimes violent, place. But from that chaos, beauty and even life can emerge. Have you ever looked up at the night sky and wondered what it would be like if we had two moons instead of one? It sounds like something straight out of a science fiction movie, right? But what if I told you that this seemingly small change could have such a massive impact that humanity might not have even existed? Let's dive into this mind-bending what-if scenario. First, let's talk about tides. Our one moon pulls on Earth's oceans, creating the familiar rhythm of high and low tides. Now, imagine a second moon. Let's call it Luna 2. Depending on its size and orbit, the gravitational tug-of-war would get intense. If the two moons were on opposite sides of the Earth, their poles might partially cancel each other out, leading to weaker tides. But what if they aligned? The combined gravitational force would create colossal supertides, far larger than anything we experience today. We're talking about coastal cities being completely submerged twice a day. The constant, extreme flooding would make coastal living nearly impossible, dramatically reshaping where early civilizations could settle and develop. These supertides wouldn't just affect our coastlines. The immense volume of water moving back and forth would act like a brake on Earth's rotation. Our planet is already slowing down, thanks to our current moon, but with two, the process would speed up significantly. A day might become 30, 40, or even 60 hours long. This would have profound effects on our climate. Imagine scorching hot, extended days followed by incredibly long, freezing nights. Most plants and animals, including the crops we depend on, are adapted to a 24-hour cycle. Such a drastic change would likely cause mass extinctions, scrambling the food web from the very beginning. And what about the night sky? With two moons, our nights would be incredibly bright. A full moon can already seem bright, but two full moons could illuminate the landscape almost like twilight. This would have a huge impact on nocturnal animals, disrupting their hunting and migration patterns. For early humans, this constant light might have offered some protection from predators, but it would have also made stargazing much more difficult. Astronomy was a cornerstone of early science, navigation, and calendar making. With a sky washed out by two bright moons, would we have mapped the stars as accurately? Would we have developed the same understanding of the cosmos that eventually led us to the space age? The gravitational chaos doesn't stop there. The two moons would be pulling on each other as well as on Earth. Their orbits would likely be unstable. Over millions of years, they could drift closer and closer. One possible outcome is a spectacular, catastrophic collision. The debris from this cosmic smash-up would rain down on Earth, potentially causing an extinction-level event similar to the one that wiped out the dinosaurs. Even if they didn't collide, one moon could be ejected from Earth's orbit entirely, or spiral inward and crash into our planet. The long-term stability we've enjoyed, which allowed complex life to evolve and thrive, would be gone. This brings us to the very origins of life. Some theories suggest that the tidal pools created by our moon were the perfect incubators for the first living organisms. With the extreme tides from two moons, these delicate environments might have been too chaotic, constantly being washed away and reformed. Would life have even gotten a foothold in such a turbulent world? And if it did, the path of evolution would have been completely different. The pressures to survive in a world with longer days, extreme temperatures, and catastrophic tides would have favored different traits. The creatures that evolve might be completely unrecognizable to us. So, would humanity exist? It's highly unlikely. A stable, predictable environment at our single large moon helped create was a critical ingredient in our evolutionary story. It gave us manageable tides, a stable 24-hour day, a protective tilt, and a relatively clear view of the universe. Without these Goldilocks conditions, the journey from single-celled organisms to intelligent, tool-using primates might have never happened. We are, in many ways, children of our moon. So the next time you look up at that single silvery orb in the sky, remember just how important it is. It's not just a pretty light. It's a cosmic partner, a stabilizing force that helped make our world and our existence possible. It is a humbling reminder that our place in the universe is the result of an incredible series of fortunate events. What do you think? What other crazy consequences of having two moons can you imagine? Let me know down in the comments. Thanks so much for watching, and if you enjoyed this journey into the cosmos, don't forget to like and subscribe for more mind-bending what-ifs. See you in the next one.